Hey everyone, welcome back to my YouTube channel. I'm Chai Shastri, and this is the fourth video of lecture series Data Science using Python. In this lecture, we will see data preparation phase to model the data, which includes how to partition the data in Python, how to balance the training dataset in Python, how to build card decision tree using Python, how to build C5.0 decision tree using Python, how to build random forest in Python. So here is our presentation. So data preparation, the foundation for building accurate machine learning models. So what is data preparation? Data preparation is a critical step in machine learning process. It involves transforming raw data into a formal suitable for training models. This process ensures that the data is clean, balanced, structured to provide optimal performance for your models. In this presentation, we will delve into key data preparation techniques. So, partitioning, creating datasets for training and testing. Why partition? Partitioning divides your data into three sets: training, validation, and testing. The training set is used to train your machine learning model. The validation set is used to tune the model's hyperparameters. The testing set evaluates the final model's performance. Python implementation. Python libraries such as scikit-learn provide functions like train, test, split to easy partition data. This ensures your model is not overfitted to the training data and can generalize well to new data. Balancing training data, ensuring fair representation. Importance: balanced datasets ensure that your machine learning model is not biased towards the dominant class. This is crucial for achieving fair and accurate predictions. Techniques like oversampling, duplicating minority class examples, and undersampling, removing majority class examples help balance the dataset. Python implementation, Python libraries like Embedded provide functions like smooth synthetic minority oversampling technique to create synthetic minority class examples. Building card decision tree. So, what is card algorithm? Classification aggregation tree is a popular decision tree algorithm used for classification aggregation tasks. It recursively partitions the data into smaller subset based on the best feature to split on. Key feature: card is relatively easy to understand and interpret. The tree structure provides a clear representation of the decision rules learned by the model. Python implementation. Scikit-learn provides the decision tree classifier class to implement card decision tree in Python. C5.0 algorithm. C5.0 is an improvement upon the card algorithm, enhancing its ability to handle complex datasets with many features. It uses a more sophisticated splitting criteria and pruning technique. Advantages are often results in accurate and robust decision trees compared to card, especially for datasets with high dimension and noise. The RPart package in R provides the C5.0 algorithm for building decision tree. You can use the RPy2 library to access R packages from Python. Now we will see how to make a decision tree with a solved example. So decision tree using Gini index. So here is our data set given here. I have written all the steps to calculate the Gini index and make the decision tree by the data given. First step is compute the Gini index for the overall collection of training examples. So there are four possible output variables: cinema, tennis, stay in, and shopping. The data has six instances of cinema, two instances of tennis, one instance of stay in, and one of shopping. To calculate the Gini index, formula of Gini index is this: 1 minus all sum of the square of all the probabilities of instances. Computation of Gini index for money attribute. So we will compute the Gini index for money attribute first. It has two possible values of rich, 7 examples, and poor, 3 examples. For money, poor. For money is equal to poor. There are three examples with cinema. So the Gini index for this is 1 minus 3 by 3 square is equal to 0. For money is equal to rich, there are two examples with tennis, three examples with cinema, and one example with stay in shopping each. So we will calculate the Gini index for this by using formula which we used earlier. So by this, we will compute the Gini index for each and every attribute. For parents is equal to yes, for parents is equal to no, and for weather attribute, for weather is equal to sunny, rainy, and windy. Now we compare all the Gini indexes of each attribute for weather, for parents, for money, and we select the attribute which has the lesser Gini index. As parents is selected as it has the smallest Gini index. Now parent will be our root. Now parent has two possibility, yes or no. For yes, or parents containing value yes, all will go to the cinema, and for no, we have to calculate further. For so computation of Gini index for parents is equal to no in weather attribute. So by the formula of Gini index, we will calculate Gini index for each attribute, and now again compare Gini index of each. So as we can see that here weather is selected as it has smallest Gini index. Now for parents is equal to no and weather is equal to sunny, we have all instances as tennis. Now for parents is equal to no and weather is equal to rainy, we have all instances as stay in. Now for parents is equal to no and weather is equal to windy, we need to split. When weather is equal to windy, parent is equal to no and money is equal to poor, we'll choose cinema. When weather is equal to windy, parent is equal to no and money is equal to rich, we'll choose shopping. As it all is given in the data set. So this is our final decision tree using Gini index, which is the implementation of card decision tree. Now going again to the presentation. So building random forest ensemble learning for enhanced accuracy. Ensemble learning. Random forests are a powerful ensemble learning technique that combines multiple decision tree to improve prediction accuracy. They reduce overfitting and improve generalization. Key components. Random forests use bagging, bootstrap aggregating to create multiple decision tree by randomly sampling data and features. They then average the predictions from this tree to make a final decision. Python implementation. Scikit-learn provides the random forest classifier class to build a random forest in Python. You can adjust parameters like the number of trees and the number of features considered at each split. So handling missing values. Missing values can be imputed, filled in using techniques like mean imputation or using the median, or removed entirely if they are insignificant. Outliers. Outliers are data points that deviate significantly from other values. They can be removed or replaced with some more representative value or treated as a separate category. So encoding categorical variables, converting non-numerical data. One-hot encoding and label encoding. This technique creates binary column 0 or 1 for each unique value in the categorical variable, indicating its presence or absence in the dataset. If the value is 0, that means it is absence, and if the value is 1, that means it is presence. Second is label encoding. This technique assigns a unique integer to each unique value in the categorical variable. It is simpler but can introduce unintended ordinal relationships. So feature engineering and selection, creating and choosing the right features. Feature engineering, this process involves creating new features from existing ones to improve model performance. This could include combining features, creating interaction terms, or applying transformation. Feature selection. This involves choosing the most relevant feature for your model, reducing noise, and improving performance. Techniques include univariate feature selection and recursive feature elimination. So Python implementation scikit-learn provides tool for feature engineering. So scaling and normalizing the data, standardizing data for optimal performance. Scaling and normalization ensure that all features have similar ranges and scales, preventing certain features from dominating the model. It improves model convergence and can enhance accuracy, and especially for algorithms sensitive to feature scaling. So this is all with this presentation. I will give you practical implementation of decision tree using cart algorithm in the description. Thank you.